Imagine a virtual world where billions of people live, work, shop, learn and interact with each other, all from the comfort of their couches in the physical world. In this world, the computer screens we use today to connect to a worldwide web of information have become portals to a 3D virtual realm that's palpable, like real life, only bigger and better. Digital facsimiles of ourselves, or avatars, move freely from one experience to another, taking our identities and our money with us. The metaverse is a vision of what many in the computer industry believe is the next iteration of the internet, a single, shared, immersive, persistent, 3D virtual space where humans experience life in ways they could not in the physical world. Some of the technologies that provide access to this virtual world, such as virtual reality, VR, headsets and augmented reality, AR, glasses, are evolving quickly. Other critical components of the metaverse, such as adequate bandwidth or interoperability standards, are probably years off or might never materialize. The concept is not new. The term metaverse was coined in 1992 by author Neal Stephenson in his sci-fi novel Snow Crash, and work on the technologies that underpin a virtual reality-based internet date back decades. Because the metaverse is largely unbuilt, there is little agreement on how it will work. Broadly speaking, however, the metaverse is a digital ecosystem built on various kinds of 3D technology, real-time collaboration software and blockchain-based decentralized finance tools. Factors such as the degree of interoperability among virtual worlds, data portability, governance and user interfaces will depend on how the metaverse pans out. The metaverse remains a domain of niche applications, used by consumers for entertainment and gaming but stopping well short of an all-encompassing virtual reality. The metaverse is controlled by large competing ecosystems, for example, Apple and Android metaworlds, with limited interoperability. The metaverse is a dynamic, open and interoperable space, much like the Internet but in 3D. Two technologies considered important to the development and growth of the metaverse are virtual reality and augmented reality. Virtual reality is a simulated 3D environment that enables users to interact with a virtual surrounding in a way that approximates reality as perceived through our senses. This approximation of reality is now typically accessed through a VR headset that takes over a user's field of vision. Haptics, including gloves, vests and even full-body tracking suits, enable more lifelike interaction with the virtual environment. Augmented reality is less immersive than VR. It adds digital overlays on top of the real world via a lens of some type. Users can still interact with their real-world environment. The game Pokémon Go is an early example of AR. Google Glass and heads-up displays in car windshields are well-known consumer AR products. The online gaming industry has decades-long experience in creating immersive virtual worlds. And to the extent a proto-metaverse has a mainstream use, the massive audiences that flock, albeit not synchronously, to the likes of Roblox, Epic Games and Decentraland suggest that playing games, building virtual worlds and investing in real estate might be it. Enterprises are experimenting with metaverse applications in the workplace that build on the virtual applications companies deployed during the pandemic to support remote work. An early application of metaverse technologies involves workplace training. One technology recently approved by the FDA is Metaverse, an AR surgical system that lets surgeons quickly sync with a hospital's digital imaging system. Digital twin avatars will not only exist on computer screens but will be rendered as AI-powered holograms or holographic images that are assigned tasks, IR reported. A CEO, for example, could activate an AI-powered hologram of himself to engage with multiple stakeholder groups at once. Metaverse for work collaboration. This includes setting up 3D rooms where employees can collaborate. Enhancing teamwork and collaboration instead of the whiteboards, sticky notes and large screen monitors that are the staples of in-person ideation. Teams could, for example, transport themselves to the Louvre Museum for inspiration, Diana said. A digital twin replication of a building could theoretically enable architects to collaborate with clients in real time on layouts and pinpoint problems and opportunities in advance of building out the space. Enabling faster learning. Interactive gameplay and simulations could speed up learning and improve outcomes by, for instance, enabling employees to learn how to operate equipment as if in real life or to practice a sales pitch for a big money client. Assessing operations in the metaverse could make it easier for executives and managers to visit a factory, distribution center, or construction site on the other side of the world, shaking hands with employees and doing inspections as if on site.